If you have data and you attempt to fit a curve to the data too much, you can overfit the model to the data. An overfitted model presents a real danger to you as a modeler. It's possible for you to produce a model that has zero error relative to your actual data points, but is actually quite inaccurate in between those data points. For instance here, well, you'll see MATLAB has already given me a warning that my polynomial is badly conditioned. So what that means here is I've modeled a few different pieces. So I have my red circles joined by the blue straight lines. So the blue straight lines would be linear interpolation. I have a red line running straight through everything, which is my linear fit. And then I have this high order polynomial that's wobbling up and down. And it manages to hit all of the points, but particularly near the ends, its wobble gets more and more out of control. It starts to oscillate wildly, even though it perfectly matches all of the given data points. Now, this is not a contrived example. It's the real way that high-order polynomials always fail in fitting data. Because of this, you will rarely see data fitted with more than a cubic model, unless there's a specific theoretical reason to do otherwise. Extrapolation, as opposed to interpolation, means predicting values outside of the effective domain of the fitted data set. So in this case, if we're looking inside of this data set, we mean between 0 and 10, which are where our observations lie. If we're modeling anything inside of this, all of our models are reasonably close to what this line shows you, whatever the physical process should be. But if you go outside of the range 10 or 0, all of a sudden you jump to points that are very dramatically distant from where you're at. Overfitting can cause this, but in general, any kind of extrapolation can lead to this kind of large deviation in behavior outside of your standard domain. So typically, one would only extrapolate if the model being fitted to is well understood theoretically. This would be like a linear spring subject to Hooke's law, or a resistor operating in a regime compatible with Ohm's law. But of course, we know that these things fail as well, right? If a resistor overheats, then it might act as a fuse and actually melt out and cut off the circuit entirely. So we have to always go back and compare whatever models we're building to observed physical reality.